Hello students, I am Dr. Witten here to give you another example of doing correlations and actually to test this new kind of software thing I have going on. So here's another example. We've got our X and Y variables, which are TV and GPA respectively. And all we need to do is get all the values that we need to plug into this big formula here. So first we are going to square all of the values, all of our X values. So 12 squared is 144. Right? So you see here I'm adding it to the X squared column over here. So 6 squared is 36. 1 squared is 1. Where are we? Yes, 2 squared, sorry, over here on the far left are the participant numbers. Don't square those. Okay. So 2 squared is 4. 5 squared is 25. Then moving on to the Y column, we square our first Y value, which is 1.2. So that would be 1.44. Squaring 3.1 is 9.61. Squaring a 4.0 is 16. Squaring 3.9 is 15.21. And squaring 3.7 is 13.69. Now we are going to multiply each X value by each Y value. So for participant 1, a 12 times 1.2 is 14.4. 6 times 3.1 is 18.6. 1 times 4 is 4. Where are we? 2 times 3.9 is 7.8. Then 3.7 times 25 is 18. Oh, sorry. 5 times 3.7, it's really hard for me to look sometimes in different ways. So, sorry. So now we are on 5 times 3.7, which is 18.5. Okay. So now we are going to add up each of these columns. So we're going to add up our X column first. And so 12 plus 6 plus 1 plus 2 plus 5 is 26. 1.2 plus 3.1 plus 4.0 plus 3.9 plus 3.7 is 15.9. 144 plus 36 plus 1 plus 4 plus 25 is 210. 1.44 plus 9.61 plus 16 plus 15.21 plus 13.65 is 55.95. And so 14.4 plus 18.6 plus 4.0, etc. is 63.3. So now we just have to plug these into this formula, and I kind of put, here we go, there. Okay, so I kind of copied it over here. So let's just go ahead and start plugging these in. So of course R is going to equal first N, which is 5. There are 5 participants, times the sum of the X times Y values, which is 63.3, this in parentheses there. Then we're going to subtract the sum of our X column, which is 26, times the sum of our Y column, which is 15.9. Over, remember our big square root. Don't forget to take that big square root. Here we have our N again, which is 5. Oops. Who can read that, right? So here. That looks more like a 5. Times 210, which is our as a matter of fact, I'm going to write that in pink, keeping consistent. Hopefully that helps you, but okay, so 5 times 210, which is the sum of our x squared column. Then we're going to subtract the sum of the x's, which again is 26, and then we're going to square that. Right. And so again, on the y side, the n is 5, of course. The sum of the y squared column was 55.95. Then we're going to subtract the sum of our y column, which was 15.9, and square that for the big square root. Okay, so now we're just solving for r. And we have r, oops. And I wonder, here, I'm going to pull this up a bit. Go away. Okay, so I'm going to get used to this kind of software eventually. Okay, so r is multiplying that out, so we've got 316.5 minus 413.4, big square root. We'll have 1050 minus 676 times 279 minus 252.81. So continuing to solve for our correlation coefficient. Oops. We'll get negative 96.5 over the square root of here we go, 374 times 26.99. Oops. Continuing on, we are going to get negative 96.9 over the square root of 10,075.56. When we take that square root, we are going to get that. Okay. R equals negative 96.9 over 100.377 for a correlation coefficient of negative 0.965. So I hope that eventually I'll get the hang of the software a little bit more, and it'll help you guys understand how to do these calculations. I hope that this video was at least somewhat helpful, and happy studying.